Well, hi, good morning, and thanks so much for joining me in my shop for day 2 on this big old radio here. So I think, as usual, I'm anxious to get it operating to any degree as soon as possible. I think with this radio, though, considering it has only a few parts in it, these old radios don't have a lot of parts, and they all look like I'm probably going to replace them anyway. And what I'm talking about are these 4 capacitors. This guy, this guy, this guy, and this guy up here. I think I should just go ahead and change those 4 capacitors. Now, I don't know for sure they're in the right place. I'm just gambling, essentially. I don't have a schematic, so I'm just gambling the last guy who worked on this radio did everything correctly, and or at least did things that work, and if I duplicate them, I won't have changed the circuitry in the radio. So what I'm trying to get at here, in sort of an oblique way, is someone has done a fair bit of work in the radio here. There's no reason to think it is still wired in its original way. They could have made various minor but significant changes in it. So that's why I'm just going to put exactly the same capacitor size back in exactly the same spot as you see them now, and we'll carry on. And then I'll try powering up the radio and see what we can get out of it. The first one I'm going to go after is this rather enormous one up here, which is tied to this ground contact here, which incidentally was holding the cover on the capacitor here. And I've put the nut back here, by the way, to make sure this is grounded properly. So we're just going to cut them out. I'm just trying to tell if it's original. You know, this is a large, heavy capacitor, and in proper engineering, this would be strapped down somehow. Wouldn't be floating here like this. That's probably a replacement. It's a weird looking thing. That's another sign it's a probable replacement. Its condition, well, we can't know. So it's right on this ground lug. And I'm going to leave the wire hanging here so I can't be confused about where it came from. So it's a 1. It's a big one. It's a big 1. Here's a more modern 1. You can see how much smaller it is, but this is pretty old too. And a modern 1 would look more like this. That looks like this 0.1 there. 1 is a big capacitor. I think we're going to test this guy right away and see what we're up to here with this. I do not stock 1s. They're expensive. And very, very seldom called for. So the way this works is I'm going to put a voltage, a DC voltage on the capacitor. A good capacitor, well, that won't matter. Once the capacitor is charged, no current will flow through it. If there isn't any current flowing, this eye is going to close a bit from where it is now. So a good capacitor, I apply the test, the eye looks like that when the test is complete. A bad capacitor, I do the test, the eye is closed. This pie-shaped opening is gone, as you'll see probably with this capacitor. It's a big one, takes some time to charge up. So for a moment the eye will close, and then it will open again as the amount of current flowing in to finish the charge gets less and less. Here we go. Okay, so the eye is slammed shut, and I'm holding this for quite a while because it could take a long time for a big capacitor to charge. Like that. A long time here. So the eye is just about to crack open at the bottom. It's probably not visible on the camera. It's just barely opening. Can't imagine it's going to go any further than that. It's still not visible on the camera, but there's a few degrees of opening there. And that's the end of the road for that one. Now, I can't see it. Continental Condenser. Continental Carbon of Canada Limited. Toronto, Ontario. 400 working volts. Okay, that first one's gotta be changed. I'll tell you what I'm tempted to do. I'm tempted to put this one in because I clicked this one out of another radio and that turned out to be fairly good. Let's just double check this one because I don't have a 1. And even though this is fairly old, it's not nearly as old. Let's see how it stands up to the deal here. This is a 600 volt one too. 400 volts, 600. Okay, here we go. Same thing. 50 volts. See it swing right open there? Do you see that? I saw that. 150 volts. Open all the way. Now this capacitor is in very good shape. I'm going to put it back in the radio. I'm going to put this not back in the radio. I'm going to put it into this radio. Oh, come on. Why don't you put a brand new part in? There's no real reason to. This guy is working just fine. So it's much smaller. Doesn't reach all the way to here. So what I'm going to do is, I guess I'm just going to run a new wire all the way over. I'll tack this in here. And okay, I'll get that installed. Okay, push that back towards the chassis. Good. Wow, that was a little more difficult. More difficult than I expected. Number 2. Let's go after this guy here. So it looks like he left the original wire here and spliced into it under this cover, and then put a new wire all the way down to put the actual lead from the capacitor down to here. How big is this guy? 0.01. Okay. Nice long leads here. So down there. Let's take a look. There's lots of extra wire here. Leave a wire here for now. .600 volt, made in Canada. You can see the splice right here, where the original capacitor is gone, and this is a replacement. Let's check out the replacement. I think I left my gizmo on here. Okay, 50 volt first test. This should charge up pretty quick, so the eye should close and whip open, just like that. 150 volts. Not going to do it. So, you know, this is typical of these capacitors at this age. They're still working to some degree, but leaky to some degree, and then it's a question of, you know, where they are in the circuit. off and nip it back a little bit. If I can avoid resoldering right down on the terminals, I kind of like to do that. See if we can pull this off now. There we are. Give me a little bit of wire. Okay. There you go. Fingers below the solder. Danger, danger. I don't think that took. I don't think the solder's sticking to the old wire. Too much. Oh, it's stuck. Good for now. Go. That's 2 done. Okay, next one. Go after this one. So it's coming right from the volume control. There's is this the volume control? It's the on-off switch. It could be the tone control. This could be the tone capacitor. And this, I don't know what they're doing here. This is where there may be a variation from the original circuit. When the fellow installed this, he may have done something, but he wouldn't change volume and tone control. This has 3 wires coming to it, which is why I think this is the volume control. This has only 2, which is why I think it's the tone control. And they commonly, I guess the thinking was, you put the switch on the tone control because the volume can be left then at its wonderful position, instead of every time turning it down to turn it off, and then you have to turn it up. You don't know how high you're turning it. Remember, these aren't instant on, right? Actually, these are pretty quick, but a normal tube radio takes a few minutes, so you could turn it on, turn it up way too high, walk across the room, and the next thing you know, you have a blasting radio coming at you. You got to run back over. So that can't happen with the tone control. The worst that can happen is the tone's not right. So you just leave the volume alone. So I think that's why they put the switch on the tone control very, very regularly. Up until somebody said, it's a waste. Or tone controls got more complicated. So this is an original wire, but I'm going to change it out. And just leave a little tail here so I can't forget where it came from. But I can't forget over here. I'll just... I think I'm just going to nip it off there. So this certainly is a replacement, a 0.1. 20%. That's how accurate these are. Dart. Well, all that's left of the word is dart, so I think there was more to it. Didn't say much else. Okay, dart, let's give you a chance. This is your chance to shine after all these years. This may have been put in. Like what may have happened to this radio is a junk box repair was done on it. Similar to what I just did with that other capacitor. I hate to call it that, but because all the capacitors are different, none of them look particularly new. This could be what the guy had in his junk box. 0.1, starting with 50 volts. Right open. 150. Right open. 250. Oh, nothing wrong with this capacitor. big 0.1. I'm tempted to put it back in. You know, I kind of keep the radio in its state, but it's already in some other state. What's the voltage on this? 600. 0.1 at 600. So I have no idea the voltage running in this radio, so I'm going to put in a big 0.1 at 600. Okay, so I've got to build a wire extension on it, just like the last capacitor and that. Okay, that's 3 of them done. And we have this last one here. Again, almost certainly a replacement. Now they've soldered it to the top of this, but this component here is actually disconnected from the radio. You can see the cut wires here. So they're using this as a ground connection. And this in turn is soldered to other black wires, which I'm guessing are ground connections. So best thing is to maintain the connection right here, just like it is. Made in Canada, 0.05 600 volt Aerovox. That's a very, very common kind of capacitor there. So what did I say, 0.01? 0.05. 0.05. Again, we don't know the voltage requirements for it. This is a 600 volts, so I'm going to put in another 600 volt capacitor. Ooh, this is that wire that's barely soldered here. Oh, what happened now? What just happened there? Something shifted a lot. Oh, okay, so it's the back of this is coming right off. Can you see there's little dimples here? A dimple. There's a dimple there. There's probably dimples all around trying to hold this thing together, and it's not working out. Oh boy, we don't want this to fail. Because it has the on-off switch built into it. Okay, great caution needed there. But I don't think there's much I can do about it. Okay, so I've left a little wire tail. Oh, don't pull. And then I go and proceed to do exactly what I said I shouldn't do. Pull on it. Duh. I suppose maybe it's true that none of us take our own advice as much as we should. Okay. This guy will make it right across. Okay, so what have we done? We've changed out the bad capacitors, which didn't seem to be absolutely terrible anyway. Certainly none of them were shorted or anything like that. We're ready to try operating this radio. Again, so I'm going to stop on the video here and get things set up to try to operate the radio. Okay, I think we're all set here now. So I got the speaker plugged in. Got my signal generator running with a signal coming out at 1 megahertz, roughly the middle of the AM band. That's a moderate signal, not terribly strong. So it's like a radio station there, broadcasting on this piece of wire right into the antenna here. So this radio is getting a good, healthy signal. And let's see what happens now. We need to turn the volume down. So the set is switched on right now. As soon as I apply power, away we go. Done some capacitor changes. Could have mucked things up a little bit, so dim bulbs are very important again. These are off right now. The initial supply voltage is the full thing, 117, going through a light bulb there. I think I'm just going to turn it down a wee bit. Start. Okay, and as soon as I flip this switch down, the power goes through the light bulbs to here, and we're in business right away. Any reason not to do this before I do it? Did I, oh yes, the quarter. I didn't make a big enough deal about finding money in this radio. Almost every radio I go into, I joke about finding, a gold bar or maybe some old bonds or something. But I found a quarter. That's the first time. Okay. Nothing's coming to mind about why I shouldn't do this. Okay, we're going to do it. We're doing it. It's being done. We're getting no bad reactions here at all. I'm looking for smoke. I'm literally looking for smoke. Smoke is a bad reaction. Here comes Peanut. Okay, we'll turn it up. That's my cat. That's not the radio. Okay. Got the big 0. We're going to raise the supply voltage, which is only at 69 at the radio. Peanut, you just come at the wrong time. Yes. So this is drawing a lot of power now. As I turned up the voltage, it drew more and more and more. So I'm going to turn, and I can't get it beyond 83 with those lights. Peanut, this isn't. Oh my God, Peanut, this isn't the right time. Peanut. No, I'm not going. I'm not going with you. I thought I was doing that. Hey, cats are people too. Okay, so what I want to do is I want to crank this down, flip this up, put this back up, flip this over to wattage. So we're running around 75 watts. That's perfect. That's exactly where it's supposed to be. Okay. Make some sound. Volume all the way up. Tone control moving. Not a sound. Let's get a look at the tubes and make sure they're lit, but I'd be stunned if they aren't. They are lit. Okay, so no sound in the speaker. Oh, Peanut, just please wait just a minute. So what we're going to do is we're going to inject some. Come here. No. Here, I'll pick him up. We'll pick him up for a while. Okay, Peanut, it's you and me together now on this. He likes working on radios, I guess. I don't know. I want to touch the top of the one of these. Here we go. Nothing from the speaker. So I think I have to prove what that speaker can do before we go any further. My poor cat. Is that right, Peanut? Are you right? Here, give a good face look into the camera there. Well, you know what he just wants to get down and get out. Okay, you're going down. Enough catness. Okay, so what I'm going to do is I'm going to shut this guy off before I forget, and then we're going to turn our attention straight to that speaker and find out what's really going on with it. Okay, Peanut, is that a good idea? Hey. Oh, he's distracted. Well, Peanut wasn't interested in me at all. He just wanted to go outside. And he won't last long out there. It's cold again. About 3-4 degrees. Okay, speaker. So there's two things going on in this speaker. One is the sound production, and the other one is a big coil that's in here. And the big coil This is ice cold. Absolutely ice cold. So one of the things that can happen to a radio that would make it go absolutely dead is this coil is open inside. If the coil is open, there's no high voltage to run any of the tubes, and everything is stone silent, which is the way this radio is. So it raises a question right away. Is that conductive? Now, knowing for sure, a little tricky, but I think we can get there. So we're just going to look for resistance. The winding here would be like 1,000 ohms or something like that. Probably on these two big pins. If I were the engineer, that's how I would do it. So there we see 2,300 ohms. So that means the coil is good. Now that also means this is the coil, this is the voice coil. Now there may be a little bit of magnetism in here. It may hear something here, I doubt it. But again, coil is good. Lower resistance. So surprisingly enough, this is a big part of the power supply right here. That's kind of surprising, I think. So that part of it is good. Now, to try to make this thing operate, we have to put current through this coil. Typically, that would be carrying, all the tube currents. So it'd be like 10, 20, 30, not the heater currents, but the actual tube current. So assuming it's 10 milliamps, that's a bad assumption. 10, 20, 30, 40, 50, 60, 70, 80. So we're looking at 100 milliamps, probably double that going through here. So the reason you need to have this current in here to make the speaker work is this is the magnet for it. This is probably the center core post of a magnet right here, maybe not. So we have to magnetize this guy before the voice coil has anything to push against, and we can even test the radio. So first order of business is put some current through this. Okay, I can do that. I have a little DC supply here. This is 100 milliamps, 200 milliamps. Give you some idea what the scale is. Put this on the big plugs. Big pins. Big pins. It might pop off. Leave it alone, we should be okay. So now I'll start running some voltage here, and we'll watch the current, and we'll see what happens. Well, it's not putting much current through. That's like hard to say there. It looks like maybe only 20 milliamps. Well, let's see if that's enough. So what I'll do now, I'm going to set up to feed a signal into the voice coil, and we will listen to what comes out. You know what, I'm not going to use this. I'm going to use my sweep generator here. Okay, so I've got my sweep generator going here. On the end of this clip lead is an audio signal that's varying in frequency, starting around 100 and going up to 8,000, I believe. So it'll be like a rising whistle. And it takes 1 second to do that journey. It'll be whoosh, 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 like that, even faster. Will we hear that? Well, that's a good question. Better back up. I don't hear anything. Now, even with the cone off, there's still enough moving there. High frequency, we should be able to hear it. It's just a little hard to clip onto around terminals. Okay. So So a couple possibilities here. One, this doesn't work, no matter what. Two, I haven't got enough voice coil signal. And three, I haven't got enough signal in the, or enough current flowing here. So the easiest one and the safest one is to increase the signal on the voice coil. So I will do that. Okay, that's everything my generator has. Oh, I can hear it. It might be very hard to hear on the video. I'm going to try to increase the field coil current. Yeah, that's all she's got. So I can't really increase it. My supply can only put so much pressure out, so the amount of current in the end is way low where it should be. But we're not trying to make this sound great, we're trying to make it sound. I'm going to stick a microphone up close to it here. Really hear it better. Sounds like birds singing in the distance right now. There. Okay. Bring up this volume alone. Okay, so this is this microphone alone. Let me slow it down. Well, there's some low frequencies in there. I mean, there should be. If any of it's in there, all of it should be in there, really. So, the problem now is the sound is really small because there's no cone connected. I thought if I just push the cone up against it here. Better. All I did was just push the cone back to where it should be. Just one piece, just a little piece there. So, is it possible for us to reshape this cone back to where it should be and glue it, tape it, whatever it takes to get it back into its proper shape? I think the answer is no, but why not try? Like, what can go wrong here? I mean, it is ruined. I can't make it any worse, I don't think. How did it get like this? Somebody must have reached in from behind and punched it forward, or something like that happened. They reached in, stuck their hand around the back here. Something like this just doesn't do this on its own. Rip it more. And you can see right down inside. So the silver thing you're seeing is the magnet that the coil is wrapped around, and then this part here, the field coil is wrapped around. Then this part here is the voice coil. Should move a little bit. It does. These are held. This one's held really rigidly by the mechanical system they got holding it together. It's very rigid, so can't expect too much movement here. You know what? I think if I wet this down and mess around with it, I can get it back into roughly its right shape. Patch this up. It's going to look terribly ugly, But I don't think it's going to matter, because this is so strong. This is held so strongly in here by the system they're using. I think in later speakers, they loosened this up so it would move more, but in loosening it up, you start introducing problems of it getting off alignment or just going wrong. So I think that's the name of the game. We just try to get the cone back in there. Yeah, good. I'm going to think about it a little bit. I don't know if I should wet it. I don't know how to proceed on this, so I don't know what to do. I'm going to just leave it for now. Maybe we'll call that the end of this video right here. And tomorrow I'll carry on, see if we can't straighten up the speaker a bit more and get back to trying to make the radio play. We kind of need the speaker, don't we?